Welcome to your second video in Chapter 10. This one deals with a specific kind of sequence called an arithmetic sequence. And we basically have two kinds of sequences in this chapter, but this one is the first one we're going to deal with. And it is a sequence that has a common difference between each term. The consecutive terms have a common difference. And you can find that, and we refer to that as D. I know that's very original. And another way to look at this, you'll determine when we're making our equations, is that that common difference becomes a constant rate of change. And you know the constant rate of change as the slope. So these equations are linear, and they will give us the slope when you find the common difference. Let's do an example. If I gave you a sequence of 7, 11, 15, and 19, I'd like you to find the common difference and then the next four terms. Well, it's pretty easy. If you just look at each term, you can determine the difference between 7 and 11 is 4. If I were to take 11 minus 7, I would get positive 4. 15 minus 11, I would get 4. 19 minus 15, I would get 4. So 4 is my D. And then to get the next four terms, I simply take that 19, I'm going to add 4, and I'm going to get the next term. So if I do 19 plus 4, I'm going to get 23. If I take 23 plus 4, I'm going to get 27. And 27 plus 4, I'm using 31. If you notice, I'm using the previous term in the next term. We had a word for that in our previous section. You remember that in 10.1? Begins with an R. We'll talk about that in a second. 31 plus 4 gives me 35. So the next four terms are 23, 27, 31, and 35. And my D is 4. Now the word you were looking for where we use the previous term in the next term is recursive. So let's develop a recursive formula for this pattern. So to get any term, the a sub n term, we took the previous term and we added the difference. So you remember we denote the previous term as a n minus 1 and then plus the difference. So that is our recursive, well, and I need to make sure that you are given a sub 1. We need to make sure we've done that. Once you're given the first term and the difference, you can recursively find the whole sequence. Now let's look at a different way to get that formula. If I were to look at, let's just look at this pattern that we did right here. Now we knew the first term was, the first term was 7. But to get the next term, I took the first term and added the difference, right? And that gave me 11. To get the next term, the 15, I took that first term and I added 2 of the differences. And that gave me 15. To get the next term, I took, again, the first term and I added 3 of the differences. And that gave me 19. Okay, and we could keep going and get the terms that we arrived at. Now let me review this. This is the first term, obviously. This is the second term. This is the third term. And this was the fourth term. And we could keep going if we wanted to. We could keep going with this pattern. But I want you to notice that the number of D's that I added is 1 less than the number of the term. So if I add 3 D's, that was the fourth term. If I added 2 D's, that was the third term. So we can come up with a formula here that says the nth term is going to be a sub 1 plus the term number, the n, minus 1 times D. That is our explicit formula for the arithmetic sequence. Now, let me scoot that up a little bit. Let me also point out that you have 4 parts to this formula. You have the a sub n, the term you're looking for. You have the first term. You have how many terms you have the n, and you have the difference. Now, a lot of times you're going to have 3 of these values, and you have to find the 4th one. So just keep that in mind when you're using the formula. Also keep in mind that this n could be anything. You can determine, find the 3rd term, find the 38th term, whatever. We're going to do some of these in a minute. But you have 4 parts to this formula, and you need to remember this formula. This needs to be memorized. Okay? But let's just talk about the recursive formula and the explicit formula. Let's try to get both of those formulas for this particular sequence. Let me scoot that up a little bit. All right. So if I have the sequence 35, 23, and 11, and I want to find both the recursive and the explicit formulas, I need to have the D. I need to find out what that is. And we can do that very quickly here. If I go 23 minus 35, I'm going to get a negative 12. So if you notice our other sequence, was positive because the sequence was increasing. This one's decreasing, so our difference is a negative. Here, I have 11 minus 23, I'm going to have a negative 12. So negative 12 is D. And I can find the formulas now. If I do the recursive, right here, I'm going to take the, and if I understand that the first term is 35, I need to have that stated, then the recursive formula is just a sub n equals the previous term minus or plus the difference. So we're going to say a sub n minus 1 minus 12. We're just going to put our difference in there. And that is the recursive formula. Now let's find the explicit. So we have the a sub n equals the first term, which is 35, plus n, we don't know, minus 1, times the d, which is negative 12. Now you can't leave it that way. We need to simplify it. So we have 35 minus 12n plus 12. Combine like terms, 35 and 12 gives you 47, and the negative 12n. I'm going to write it as negative 12n plus 47 equals a sub n. Also, that makes it very easy to look at that and see how that is linear and how that negative 12 is the slope, the rate of change. All right, let's try one where we're finding a specific term. So if I want to find the 38th term of the given sequence, I first need to calculate the D again. So let's look at each term, and this is again, it is decreasing. No, this one's increasing, I'm sorry. Negative 29 to negative 2. That has a difference of 27. And if I go negative 2 to 25, that also has a difference of 27. So that is our D. Let's talk about what else we know. We know that we're going to let n equal 38, because I want the 38th term. I know the first term, that's negative 29. So here I have 3 out of the 4 parts to that equation that we talked about right here with the explicit formula. So we can plug those in and find the a sub 38th term. Okay? That would be a sub 38 equals the first term, which is negative 29, plus n minus 1, which is 38 minus 1, times the d. Excuse me. Now we just need to clean that up. So this is 37. 37 times 27 and negative 29. And that gives you a beautiful 970. Now that's a lot faster than sitting there with that sequence and adding 27 each time until you get to 38 terms. This is much quicker. And so we like this formula, and it helps us in finding very large number of terms in relatively easy work. Let's try another one. In addition to just finding specific terms, you can determine the missing term, which is called an arithmetic mean, between known terms if you have a known arithmetic sequence. So, for example, if I want you to determine the sequence with 6 arithmetic means between 12.4 and negative 24.7. So I want you to find basically the 4 middle numbers between those two. Let's think about what you have. You know that this is a sub 1. You know that this is a sub n, or a sub 8. And you know that n is 8. Because you have the 2 terms and you're going to find the 6 means, and so you need the 4 in the middle. So let's plug it into our equation. That means that we have the 8th term, we have negative 24.7 equals the first term, 12.4, plus n minus 1, which would be 8 minus 1, times d. Well, we don't have d. So here again, you have 3 out of the 4 parts of the equation, and you can solve for the others. We know that that is 7. And so when you move that 12.4, subtract that to the other side, you'll get negative 37.1 is 7d, so that you know d equals negative 5.3. Now that you have d, you can calculate the middle terms. So, for example, let's start with 12.4, because that's our first term. And we are just going to go each time. Now I'm going to subtract negative 5.3. So, I mean, you can do this longhand. You can just put that in the calculator and just keep subtracting each time. The next term would be 7.1. Then if I subtract 5.3, I'm going to get 1.8. Subtract 5.3, I'm going to get negative 3.5. Subtract 5.3, it's negative 8.8. Subtract, I get negative 14.1. Subtract, I get negative 19.4. And subtract, I better get my 24.7, or I goofed. And I got that. So that gives you the 6 terms between the 12.4 and the negative 24.7. Now when you come back, we're going to talk about the arithmetic series, which is when you take the sum and you get the sum of all the terms in the sequence. And we did this before in the first lesson. And we followed this nice formula here. And we're going to find the sum of a sequence. And you can use the formula, but if you'll notice, let's talk about this a little bit at the end of this video. If you'll notice, here's the sum of n terms. So you need the n. You need the first term plus the last term. And then you have the sum, you have the number of terms, you have the first term and the last term. So here again you have 4 parts. If you notice, this does not have a d. But the d is encompassed in that a sub n, right? Because that a sub n is the formula of the first term plus n plus 1 times d. So you can work that out, and I think I said n plus 1, I meant n minus 1 times d. And so you can work it out if you have the difference.